Okay, so to do annotate. So if we've got two sets, so we're mapping from A to B. Actually, let's do something. Yeah. So we've got A, B, C, D, E. And let's say that there's also 4 here. So if I were to look at the inverse image of a set, well, the most basic sets that I would have would be the singletons. So it's kind of hard to see this anymore, but got the inverse image of 1 would be the set AB. The inverse image of 2 would be the set C. The inverse image of 3 would be DE. And the inverse image of 4 here would be, the inverse image of 4 would just be the null set. And then if I want to do the inverse image of 1, 2, it would be the union of these guys. So the inverse image of these, it's basically just asking, is in the same set as. So that's going to be an equivalence relation, which means that it's transitive and symmetric. So this is basically the same thing as also saying objects in this set that map to the same object or the same collection of objects. So usually when you have same, that's a pretty good indicator that it's going to be an equivalence relation, which also means that it's going to be transitive and symmetric. Because if A and B map to the same object, then B also maps to the same object as A. And if A and B map to the same object and B and C map to the same object, then A and C are going to map to the same object. And then also, obviously, A is going to map to the same object as A maps to. Does that make sense?
Yeah, thank you.
Cool. Do people have particular other questions that they want me to go over, or should I just go straight down for now?
I actually had a question from last quiz. With the question where it asked if basically one relation was always within one of the other relation, I kind of struggled to form that proof. Would you be able to do the setup for that?
Yeah. Oh, no, do not delete. That is very bad. No, right here. Actually, it wouldn't have been that bad. Okay, so begin. So right here, prove that 1 cube is within 1. Prove that the cube of any integer is within 1 of a multiple of 9.
Yes.
Okay, so this is going to be a proof by cases. And the 3 cases that I'm going to break this up into are case 1 is our integer n is equal to 3k, so it's a multiple of 3. Case 2, n is equal to 3k plus 1. And case 3, n is equal to 3k plus 2. And this is the equivalent of also saying 3k minus 1, but we'll leave it as plus 2 for now. So for this guy, it's pretty clear. Then n cubed is equal to 27k cubed. 27 is a multiple of 9, so this is definitely, so this is a multiple of 9. So 9 times 3 times k squared. So that works. In this case, then n cubed is equal to, so what do we get? We get 27k cubed plus, anyone know this from the binomial expansion? Oh, sorry, 1, 2, 1, 2, 1, and then we get 1, 3, 3, 1. right? So that tells me that this is the 3k all squared plus, then I get 3 times 3k squared plus 3 times 3k. And then I get plus 1. So in this case, what do we have? We have this is right here is a multiple of 9. This right here is a multiple of 9. This right here is a multiple of 9. So I have the sum of 3 things that are a multiple of 9 plus 1 is equal to, so I can pull out a 9 times 3k cubed plus 3k squared plus k, all plus 1. So this is within one of a multiple of 9. And then this guy, if we would do n cubed is equal to, we would again get 27k squared plus 3 times 3k squared. But this time we would also have to write out the 2 to the 1. Here we had an invisible 1 to the 1 plus 3 times 3k times 2 squared. Here we had an invisible 1 to the 1 squared plus 8, or 2 cubed here. So these guys are also multiples of 9, right? So we get 9 times 3k squared plus we would get 2k squared here plus oh sorry, this should be 6k squared plus 4k and that's plus 8. So this is a multiple of 9. 8 is 1 away from a multiple of 9, so it works here. So it works for all 3 cases. These cases are exhaustive, therefore it works. Does that make sense?
Yeah, thank you.
Cool. Do I have any other particular requests or? No?
Oh no, just a sample exam. I think that would be good.
Well, I mean, I gave you guys an actual exam, so
Oh, okay.
yeah. So you guys have unlimited time on it. I mean, not unlimited time, but like 52 hours or something like that. And you guys can ask me questions about it. It's up online already. So this question right here is basically the same as one that you guys had in your homework. So I'm not going to go over it with the exception of this right here. Why does this proof not work for the square root of 4? It's going to be that that the square root of 4 is an integer. So so you don't get that it has to be divisible by 2 at that point. Or you get that it's divisible by 2 instead of, yeah. So what is the contrapositive of if it is sunny? Tomorrow we will go to the beach. So this is P implies Q. This becomes not Q implies not P. So if we don't go to the beach, tomorrow, then it's not sunny. Or it's not sunny tomorrow, just to keep to the structure, even though it's kind of more awkward to say in English. So I have no other questions that people actually want me to answer here.
I just have a general question for the exam.
Sure.
When we do combinations and stuff, do you want us to like find the actual number, or can we just leave it in the formula?
if it's not something that's obnoxious to write out as an actual number, then write it out. So there's like one where you have to do like a chooses function with 5, write that out. But when you're doing the decks of cards, you're going to have something along the lines of choose from 50. That's going to be a massive number. Don't worry about writing that out.
Okay, thank you.
Someone else was saying something, I think, right there.
Oh, I mean, I thought it was going to be a timed exam, but that's good that it's like a take-home type of exam.
Yeah, exactly.
Okay.
I was going to make it a timed exam, but I thought that it would probably, the length of it would probably screw over a lot of people, and also that the questions would probably just be easier for people to write up by hand rather than turn it in here.
Yeah, so we can just turn it in the same way that we turn in our homeworks, like just scan it and then turn it in.
Yeah, exactly.
Okay, sounds good.
Is that it? Do people want me to continue going over these, or would you prefer just move on with your lives? I can do
I
it.
think that was all the questions I had.
Okay,
Yeah, same here. I think I'm good.
Yes, same here.
cool.
Thank you.
Have a good day.
Thank you.
Thank you for the help.
No problem.